All right, so class, as you can see the slide here, it shows the okay, where are we? All right, yeah. All right, so here it shows multiple IRR. All right, as you can see, in the same question, there's a possibility of getting more than one IRR. All right, here is you have 25% and also 400%. How is it possible? All right, if you use two different discount rates, one at high, one at a very low, you could get two IRRs, even if it's a same question, right? So that was an issue. All right, that was an issue with multiple IRR. And another issue, another weakness, as we have learned, is the reinvestment assumptions, where the reinvestment assumption in IRR is unrealistic, whereby if you have a if you have a cushion that gives you 40% IRR, a project, let's say a project gives you 40% IRR, you cannot expect to reinvest your cash flow at a 40% return. All right, that is highly unlikely. So that is why this reinvestment rate assumption is not practical. All right. So let's move into the next. All right. So this technique is modified internal rate of return. All right. This is because of several shortcomings in IRR. All right. Even with those shortcomings, managers still prefers the method because the way it shows the return, which is in percentage. So the managers do prefer this method. So in order to get a solution for all the weaknesses in IRR, they come out with a modified internal rate of return, MIRR. In MIRR, you tackle one of the main things, actually two of the weaknesses actually. One weakness is the reinvestment assumption. All right, so for the unrealistic reinvestment assumptions, was replaced with MIRR having the cost of capital as the reinvestment rate. All right, cost of capital as a reinvestment rate is realistic, but all right. So the first weakness was replaced with reinvestment rate at the rate of cost of capital, and the next weakness would be getting more than one result, right? With MRR, you'll get only one result, all right? So that is how they have tackled both the weaknesses in IRR by creating MIRR. And the formula would be terminal value divided by initial outlay or initial investment, the whole thing power of 1 over n, the number of periods, minus 1. So that is your MIRR. So this is an illustration, right? So to talk about what is terminal value, okay? So let's say you earn, this is a project, assume a project. So this is the cash flow that you earn for the next 5 years. The cash flow you receive in year one, T1, right? You earn 700,000. You won't just keep the money idle, right? So usually what the company will do, even though the project's finished at end of the fifth year, the money you received earlier, you will not keep it idle, you would reinvest. All right, you will reinvest so that you get some additional return, right? So the 700,000 you reinvest for 1, 2, 3, 4 years. All right, so if you have duration is 5 years, you get the money end of the year, you have 1, 2, 3, 4 years remaining for you to reinvest. All right, so 700,000, let's assume your interest, all right, is 13%, or your cost of capital is 13%, power of 4. because you're reinvesting for the next 4 years. So your 700,000 becomes 1.141 million, right? So 700,000 after reinvesting until the end of the project, which is for reinvesting at 4 years, you get 1.14 million. The same applies in year two. Year 600,000 you reinvest for 1, 2, 3 years, therefore power of 3. All right. So this you reinvest for 2 years. All right. This year for 400,000 you reinvest for 1 year, and whatever you receive in year five, you cannot reinvest because there's no longer any duration for you to reinvest because the project ends in year five. So that is why 300,000 is 300,000. So you're adding all this together, you get 3.39 3,397,519.73 cents. So this is your terminal value, right? So whatever your cash flow, whatever the reinvested amount accumulated together, that value is terminal value. All right. So let's do an example here. Your discount rate is 10%. You require to calculate MRR for two projects A and B. This is your initial investment. This is your income for A. This is your income for B, right? So let's calculate. Your PV of your cash flow is times 0 is 10,000. And you are required to calculate your future value of cash flows at year 3 at 10% return. Alright, so class, you can start writing it down. Alright, so this is first year 5,000. Alright, so write 5,000 times 1.1 power of 2. Alright, so class, the first thing, write on 5,000. Alright, there's nothing to do. So 5,000 times 1.1 power of 2. Alright, because you receive in year 1 5,000, you reinvest for 2 years, right, at the rate of 10%. You add 1 in front because you are adding back the capital, right? So 1.1, so 5,000 times 1.1 power of 2 plus 7,000 times 1.1. All right, because it's power of only 1. So 5,000 times 1.1 power of 2 plus 7,000 times 1.1 plus 9,000. All right, that is how you calculate your terminal value. So class, if you add up all that, you should be getting 22,750. So that is your terminal value. So terminal value divided by your initial investment 10,000, the whole thing power of 1 over 3 minus 1. Alright, so remember the minus 1. You will be getting 31.52%. Alright, 31.52%. So that is your MIRR for question A. So how do you, what would be your decision making if we evaluate the project A? Do you accept or reject? So IRR, MIRR, the way you make a decision is, the rule is the same, which is for IRR, if it's more than WACC, you accept. Same goes to MIRR. If MIRR more than WACC, you accept. So for A, your MIRR is 31.52%, which is more than your cost of capital, which is 10%. Therefore, you accept project A. Alright, so class, why don't you do this? All right, 7,000 times 1.1 power of 2 plus 5,000 times 1.1 plus 2,000. All right, so you add it all together, you should be getting 18,000 18,390. Sorry, you should be getting 15,970. Right, your terminal value for question B is 15,970 power of 1 over 3 minus 1. All right, so you should be getting 31.64%. All right, so based on answer in B, if it's independent, you can accept both the project, right? Because it's more than cost of capital. But if it's mutual exclusive, you need to choose the higher one. So the higher one would be project B, right? Even though it's slightly higher, you still need to choose the higher MIRR. So therefore, you accept project B. All right, so let's look at the strength and weakness of MIRR. So MIRR overcomes two major drawbacks in IRR, all right, elimination of multiple IRRs and also the reinvestment rate. Helps in measurement of sensitivity of an investment towards variation of cost of capital. Okay. The weakness of IRR would be may lead to suboptimal decision making when multiple investment options are being considered. Right. So this is not as good as NPV. NPV give you the exact amount of uh, wealth that can increase in a company, right? That is how in detail how granular the company's income increases. All right, the value, the wealth increases. MRR does not tell that, and MRR can be hard to understand to certain people. Right, if you tell some other method like payback period, like NPV, the way it calculates might be easier to understand. All right, so compared to MIR. All right, so let's do an example here. All right, so let's calculate NPV IRR payback period when the cost of capital is 10%. All right, so you have two investments here. Investment A and investment B. All right, investment A and investment B has the same initial investment, which is 10,000, but investment A gives you return only for 3 years, while investment B gives you return for 5 years. Right, nevertheless, you need to calculate NPV IRR payback period with the cost of capital of 10% to indicate which projects is worthwhile to undertake, which is better than the other. All right, so let's start with NPV. All right, so 5,000 year 1, 2, 3, 5,000 year 1's cash flow times with the discount rate year 1. All right, so class, these things you can actually get from the PV table. right? Under 10%, year 1, year 2, year 3. All right, you can get these informations there. And then the cash flow times the discount rate, you will be getting the present value table. All right, then you minus the present value of the outflow. That's the initial investment. So all these are present value of inflows minus the present value of outflow. You would be getting 177 for investment A. And for investment B, on the other hand, the same method, cash flow times with the discount rate to get present value, add up all together and minus your initial investment, you get 1,414 as your NPV. All right, so that gives you so once you have already calculated NPV for both part A, part B, then you can decide which one you can accept, right? Of course, you choose the one with the higher NPV. Therefore, project B based on NPV. All right, so next would be, of course, using payback period. All right, so class, all right, so let's, okay, before we go to payback period, let's calculate for IRR. So for IRR, as I mentioned earlier, we need two NPVs. One has to be positive, one is negative. One is positive that you've already calculated, right? Both also you have positive. So now what you have to do is you need to calculate another NPV that gives you negative value. All right, you need to find one with a negative NPV. So what you have to do is you need to change the rest of the workings will be same except for one. Here you need to change the discount rate. From 10% discount rate, you change to, let's say, 20%, right? Don't try with 11%, 12%. Most likely you will still get positive. So try, let's say, 10% higher. Try 20%. If you can't get negative 20% discount rate, try 30%. So don't try one by one, you end up wasting time. So try with 20%. All right, so class with 20% IRR, right? So with 20% IRR, you would be getting 0.833. Here you get 0.694, and here you get 0.579. All right, therefore you get 4165. Here you get 34701158, and then you minus the 10,000. Your NPV using 20% would be negative 1,207.